Now, when we set out to divide a polynomial by a monomial, we can use long division to organize our thoughts, but things work out much more nicely than they did with numbers, because we can always divide any two monomials. Let's see an example. Let's say we want to divide this polynomial by the monomial 3x squared y. Now I'm going to use a long division bracket to organize my thoughts. I'm going to write my 3x squared y on the outside, and I'm going to write my dividend polynomial on the inside. But now I can just go through term by term and divide each monomial by 3x squared y. Remember, when we divide monomials, we divide the coefficients. So 5 divided by 3, that's just 5/3. X squared divided by x squared, that's just nothing. Y cubed divided by y, that's going to give me y squared. What else? Next term. Notice I didn't need to do any subtracting because there was nothing left there. There's never going to be anything left when we divide two monomials. It's always going to just work. Next term. 3 divided by 3 is 1. I don't need to write the coefficient 1. X to the third divided by x squared, that's going to be just x to the first. Y divided by y, again, just 1, no need to write it down. Next term. The coefficient is negative 24. Negative 24 divided by 3 is negative 8. X squared divided by x squared is just 1, no need to write it down. Y squared divided by y is just y. Okay, last term. 33 divided by 3 is 11. X divided by x squared. X is x to the first power. When we divide, we subtract the exponents. Oh, that's just x to the negative 1. Ooh, that means that my answer isn't actually going to be a polynomial. We'll talk about that in a second. But we can do the division. X to the negative 1, y squared divided by y is just y. So the result of my division is going to be 5/3 y squared plus x minus 8y plus this last term. I want to work with this last term a little bit. I've got 11 x to the negative 1 y. I could just leave this term this way, but I want to make sure that anyone reading my answer doesn't mistake it for a polynomial. Instead of writing the negative exponent, I want to write x in the denominator. Remember, x to the negative n just means 1 over x to the n. So my last term is going to be 11y over x. What we've got here is a fraction part. This is just like in long division when we give our answer as a mixed number. The result of our division happens to have a fraction part. This is a thing that can happen in division, And we don't need to do anything special to see that it happens. When dividing by a monomial, a fraction part might just turn up naturally. Let's see another example. Let's say we have this polynomial division problem. Again, I'm going to set up a division bracket to help me keep track of what I'm doing. 6x to the fourth plus negative 18x to the third plus 22x. But now I just need to divide term by term. I need to divide 2x into 6x to the fourth. 6 divided by 2 is 3. X to the fourth divided by x is x to the third. Negative 18 divided by 2 is negative 9. X to the third divided by x is x squared. 22 divided by 2 is 11. X divided by x is just 1. I don't need to write that in. So I get 3x to the third minus 9x squared plus 11. This time I didn't have a fraction part. This time my monomial went in evenly. How did I know that that happened? Because in the end, at the end of the problem, I had no negative exponents.